Hello, my name is Junior Kong, and today I'll be talking about torque. Now, what is torque? Torque is a type of circular motion. Other type of circular motion includes centripetal motion and radial motion. Torque is a turning force that causes an object to rotate about an axis, similar to normal force, which causes an object to accelerate in linear motion. Torque is the force of an object to move in rotational motion. Torque applied to an object will cause an angular acceleration. In short, torque basically is how hard you rotate something. How to find torque? First, torque is equal to force times distance. However, it is important to keep in mind that force needs to be perpendicular to distance. If you take a look on the image on the right, the force is perpendicular to the distance of the object. The torque will be measured in units of Newton meters, also written as capital Nm. Moving on, all the problems regarding torque will use the formula torque net equals torque clockwise minus torque counterclockwise. I will dive deeper into this problem later on. It is important to understand that when the object is balanced, torque net will equal to 0. Steps to solving torque problems are first labeling the quote-unquote axis. Axis is the point at which the object rotates around. On the image on the top, the axis will be located on the bolt as the wrench will rotate around the bolt. Then you label the force and the distance and attempt to solve the problem using the given equation of torque net equals torque clockwise minus torque counterclockwise. Before diving into the example problems, I will explain to you about torques in real life. First, torque can be seen in seesaws. If you think about how seesaws work, the person on the left and right will move up and down, taking turns. This process is using the idea of torque. If you look at the image on the right, the axis is located in the middle of the seesaw. The person on the left takes the part of counterclockwise torque because their gravity is pulling them downwards from the left, rotating around the axis. The person on the right will be the clockwise torque. The distance will be how far they sit apart from the axis or the middle, and their force will be their force of gravity. Similar to seesaws, wrenches also use torque because wrenches rotate around the bolt. The distance will be how far you hold the wrench away from the bolt, and the force will be how much force you put into pushing the wrench. Next, buildings are also using torque because they are held up against each other through beams. In more simpler terms, we are able to find the force of each beams in the building exerted in order to balance the other parts of the buildings. I'll explain more about this in the next slide. Here, I will show you some example problems and how to solve them. In this problem, we are finding the force the wall exerts to hold up the beam. To start off, we will label the axis, force, and distance. Since we are finding the force of the wall, we put the axis on the other side of the wall. Then we can identify which part is clockwise and counterclockwise torque. The beam that is pulled down by the gravity will work as the clockwise since it's moving in a clockwise pattern, and the wall that is holding up the beam upwards will work as a counterclockwise torque. After we have identified all the needed factors, we can write down the equation down to solve. For torque net, We put down 0 because buildings are always going to be in balance, since they are stable and not moving. For clockwise torque, we see that the distance of the beam is 5 meters. However, we need to understand that center of gravity is always at the middle of the object. And for this part, since the force is the force of gravity, we need to calculate the distance only up to half of the object. This means that the equation will be 2.5 for this distance and 9.8 times 10 for the force part. 9.8 stands for the numerical value of the acceleration of gravity. Lastly, we found the counterclockwise torque part, which will be 5 times force of wall, which will be the value we need to find. After we find the values of everything and isolate the force of wall, we will get the answer as 49 newtons of force. In summary, torque is a turning force that causes an object to rotate about an axis. Torque applied to an object will cause an angular acceleration. Torque is equal to force times distance. Torque net equals torque clockwise minus torque counterclockwise. This equation will be used when solving all torque-related problems. When balanced, torque net will be equal to 0. Center of gravity is always at the middle of the object, meaning when calculating the distance of an object that uses force of gravity and torque, you need to make sure the distance is only up to half of the full distance. Some real-life examples of torque are seesaws and wrenches. This wraps up my lesson on torque, and thank you for watching.